Once we have structures, we can create more complicated data structures using combinations of things. For example, we could have a vector of structures. To store a database of information in MATLAB, we can do that using a vector of structures, or in other words, a vector in which every element is a structure. For example, if we wanted to store information from a medical experiment, and what we wanted was information on the subjects, the information for each subject might include a subject number, the person's height, and the subject or the person's weight. So each structure would store three fields: the subject number, the height, and the weight. Then all of these structures would be stored together in one vector so that you could loop through them to perform the same operation for every person, or have MATLAB vectorize the code. For example, I'm going to create a vector of structures for two subjects for this medical experiment. Each of the structures is going to have three fields: subject number, height, and weight. So we create a vector, first of all, with the second element. The reason we do that with the second element first is that that will pre-allocate this vector of structures to have two elements. And then I create the first element, subvar sub1, again as a structure that has three fields for the subject number, the height, and the weight. So this is going to create a vector of structures. So we have a vector that has two elements in it. I'll draw it like it's a column vector. And each element in this vector, so each element is going to be a field that has three things, and I'll just abbreviate here: the subject number, the height, and the weight. Now, in MATLAB, you can take all of the fields, for example, all of the weights, and group them together by just saying subvar.weight inside of square brackets. That's a nice way of grouping together all of a particular field. Here's another example. Here's a vector of structures called packages. So the name of the variable is packages. In this case, it's a vector that has three elements, 1, 2, 3. Each element in packages, so each one of these elements is a structure that has four fields: item number, cost, price, and weight, or rather code. So what this might represent is we sell a bunch of software packages, we have an item number for each one, the cost to us, a price we pass on to the customer, and then maybe some kind of character code, like a G means a game or an L means a language or something like that. So we store all of these structures of information on different software packages in a vector of structures. So it looks sort of like a matrix, it looks like a table, but think of it as a column vector of structures. So we have a vector that has three elements in it. So again, we have the indices 1, 2, 3. Each element in packages is a structure. So if I said something like packages sub 1, packages sub 1 is the structure that has the item number of 123, the cost of $19.99, price of $39.95, and a code of G. So packages sub 1 is a structure, so within that I can use the dot operator to refer to a particular field within the structure. For example, I could say packages sub 1 dot cost, and that would be $19.99. So here's your third question. Write general statements using the programming method, hint using a for loop, that will print the item number and the code fields for each of these structures in a nice sentence format. We can also have nested structures. A nested structure is a structure in which at least one of the fields is itself a structure. Once you've created that, to refer to the inner structure, you need to use the dot operator twice. So for example, you'd say the structure name dot, and then the name of the field within that, which is itself a structure, so the inner structure, dot, and then the name of a field within that. To create a nested structure, you can nest calls to the struct function. For example, the following creates a structure for a contact that includes two things: the person's name and the phone extension. The name is itself a structure that has two separate fields for the first name and the last name. So when we create our contact info variable, we use the struct function, and we have the two fields on separate lines to make it easier to see. So for contact info, we have two fields, CNAME for the contact name and phone ext for the phone extension. The contact name is a structure itself that consists of two fields, last and first. So for example, to refer to the last name, we would say contactinfo.cname.last, and that would give us the person's last name, which is Smith.